Assalamualaikum warahmatullahi wabarakatuh. My name is KHAIRUNNIZA Medical ANUAR and my mentor number is 291531. I will explain the API. How the API will integrate into the app. Number one is fetching city coordinates. When a user enters a city name and clicks the search button, the app uses the Open Map geocoding API to get the latitude and longitude of the city. To get the city coordinates function, construct the API URL using the enter city name and send a fetch request to the API. Number two is fetching weather data. Once the coordinates are obtained, the get weather details function is called. This function constructs the API URL for the Open Map weather forecast API using the latitude and longitude. It sends a fetch request to the API to get the weather data. Number 3 is fetching user coordinate. When a user clicks the location button, the app uses the browser geolocation API to get the user current location, latitude, and longitude. To get user coordinate function, send a fetch request to the Open Weather Map reverse geocoding API to get the city name corresponding to the coordinate. Number 4 is event listener. Event listeners are set up to handle user interactions such as clicking the search button, location button, and pressing the enter key in the input field. For the summary, the app integrates the Open Weather Map API by number 1, fetching city coordinate using geocoding API based on user input. Number 2 is fetching weather data using the weather forecast API with the obtained coordinates. Number 3 is fetching user coordinate using browser geolocation API and the reverse geocoding API to get the city name. Number 4, handling user interaction with event listener to initiate API call based on user action. For data manipulation and visualization, the app uses JavaScript and external library to manipulate and display weather data. The primary external library used for visualization is chart.js. Now, data manipulation. Number 1 is filtering and formatting weather data. The weather data fetched from the Open Weather Map API include multiple forecasts per day. The app filters this data to get a unique forecast for the next 4 days. Number 2 is temperature conversion. The temperature data from the API is in Kelvin. It is converted to Celsius by default and can be converted to Fahrenheit if the user requests. For visualization with chart.js, number 1 is creating weather card. The create weather card function generates HTML for displaying current and forecast weather data. This includes temperature, wind speed, humidity, and weather condition. Number 2 is updating the temperature chart. The update temperature chart function uses chart.js to create a line chart that displays temperature trends over the next 4 days. The chart is updated with the label and temperature data. Lastly, adding event listener. The app set up event listener to handle user interactions such as searching for city, using a current location, and toggling temperature units. For summary, the app uses JavaScript and chart.js to manipulate and visualize weather data. Number 1, filter and format weather data to display only relevant forecasts. Number 2 is convert temperature unit between Celsius and Fahrenheit. Number 3 is generate HTML to display current weather and forecast. Number 4, use chart.js to visualize temperature trends. Number 5 is handle user interaction with event listener to fetch and display updated weather data. For calculation and conditional logic, the code performs various calculations and use conditional logic to process and display weather data effectively. Here a detailed breakdown. Temperature conversion. Number 1, converting temperature from Kelvin to Celsius and Fahrenheit. The weather data from the API is in Kelvin. The code converts it to Celsius by default and to Fahrenheit if needed. Number 2 is updating the temperature charts. When updating the charts, the temperature are converted to Fahrenheit if the current unit is not Celsius. For the conditional logic, number 1 is creating weather card. The create weather card function create different HTML structure for the current weather card, main card, and the forecast card. Number 2 is handling API response. The get weather detail function processes the data returned from the weather API. It filters the forecast to get unique day and populates the weather card and charts. Number 3 is geolocation handling. The get user coordinate function uses the browser geolocation API to get the user current position. It handles success and error case appropriately. For the summary, the code performs various calculations and uses conditional logic to process and display weather data. Number 1, temperature conversion, converting temperature from Kelvin to Celsius and optionally to Fahrenheit. Number 2 is conditional logic in HTML, generating different HTML structure for current weather and forecast card. Number 3 is API response handling, filtering and processing API data to extract relevant forecast. Number 4 is geolocation handling, getting user coordinate and handling success and error cases.
This defines an asynchronous arrow function named fetchNewsArticle, which will handle fetching news article. This line logs a message to the console indicating that the process of fetching news article has begun. It's useful for debugging and monitoring the execution flow. The const URL line constructs the API endpoint URL. The URL is the base URL of the API endpoint, while the API token needs for authentication or authorization to access the API. It passes as a query parameter. This parameter, which is language equal to English, specifies that the news article should be fetched in English. The limit of 38 parameters specify that a maximum of 38 articles should be fetched in one request. The cache error line caches any error that occurred during the execution of the try block. The console error failed to fetch news article error is a log-on error message to the console, indicating that the fetching news article failed and include the specified error. Document query selector failed to fetch news article update the text content of an element with an ID news result count to inform the user that fetching news article failed. Next, we will need to update the HTML content of news container, which should be a reference to an element in our HTML to display a message indicating that loading article failed. The try function includes the code that attempts to fetch and handle news article from the API. The const response await send an asynchronous GET request to the specified URL to fetch news article. Parse the JSON response from the API into the JavaScript object data, which is the line const data await response.json. This code snippet is responsible for reinitializing a carousel component in our web application. First, we select the cursor element with the ID news carousel using document.querySelector. Next, we check if the Bootstrap framework window.bootstrap is available and if the Bootstrap carousel class is defined as a function. This ensures we have the necessary library loaded for carousel functionality. If the conditions are met, we initiate a new bootstrap.carousel object with myCarouselElement as the target element. We configure it with options such as interval and wrap. Our integration with the external libraries use Bootstrap and JavaScript. For Bootstrap, we utilize Bootstrap carousel component to enhance user interaction and display dynamic content. Next, for the JavaScript, we control the initialization and behavior of the carousel, leveraging Bootstrap functionality for seamless integration. This code snippet is responsible for reinitializing a carousel component in our web application. First, we select the cursor element with the ID news carousel using document.querySelector. Next, we check if the Bootstrap framework window.bootstrap is available and if the Bootstrap carousel class is defined as a function. This ensures we have the necessary library loaded for carousel functionality. If the conditions are met, we initiate a new bootstrap.carousel object with myCarousel element as the target element. We configure it with options such as interval and wrap. Our integration with the external libraries use Bootstrap and JavaScript. For Bootstrap, we utilize Bootstrap Carousel component to enhance user interaction and display dynamic content. Next, for the JavaScript, we control the initialization and behavior of the carousel, leveraging Bootstrap functionality for seamless integration. The condition becomes true if either of the check fails. This means either there is no data or the data array is empty. So, we calculate the length of the data.data array, which calculation is crucial to determine if the array contains any item. A length of 0 indicates that the array is empty, and hence no articles are available to display. If the condition, for example, is true, the error logging will pop up. This helps in debugging and maintaining log for issues related to data fetching. Next, there will be also UI update. This updates the user interface to inform the user that there is no article available. It targets an element with the ID news result count and set its text content. The logic here is oriented more toward responding to an error rather than processing numerical data. So, for conditional logic, the code doesn't specifically use if statement within the cache block. However, the nature of a cache block itself represents conditional logic. It executes only if an error is thrown in the associate try block. This error catching acts on an implicit condition of whether an error occurred or not during the execution of the try block code. Essentially, the cache block is the condition, and its execution is contingent upon the presence of an error during fetch operation. This is how conditional logic is implemented in error handling scenario, differing from the typical use of conditional statement like if to check condition directly.
Assalamualaikum warahmatullahi wabarakatuh. My name is DAMIA binti Muhammad NAZRI 291763. So, welcome everyone. Today I will be presenting on Malaysia InfoXplore for OpenStreetMap API, one of the functions in our web application designed to provide real-time location information in Malaysia. Let's start with location API integration. We use leaflet.js to display interactive maps. The map is centered on Malaysia with default view set to a zoom level of 6. You can see from the code, we integrated the OpenStreetMap.API tile layer to provide the map visuals. Additionally, we use the leaflet control geocoder to allow user to search for location and see them marked on the map. To get the user current location, we employ the navigator.geolocation API. The watch position method continuously update the user location and accuracy in real time. Now, let's talk about data manipulation and visualization. For location, we use leaflet.js to visualize the location data dynamically. The geolocation data is updated in real time as the user's position change. That ensures that the map always displays the current location accurately. You can see from the code here. Now, let's dive into the calculation and conditional logic. We display the geolocation accuracy using a circle with a radius proportional to the accuracy value provided by navigator.geolocation API. If the user denies access to their location or if the location cannot be determined, we handle these errors using conditional statement. For example, if an error occurs, an alert is displayed prompting the user to enable location access or informing them of the inability to retrieve their location, like in this code. You can see the conditional part. Okay, for the main feature of the app is designed to provide user with real-time weather information for a specific city or their current location, along with visual representations of temperature trends. Here are the main features. and how user can interact with them. Number 1 is search for weather by city name. User can enter the name of the city to get the current weather and 4 days forecast. User input the city name into the search bar and click the search button or press the enter key. Number 2 is use current location to get weather. The app can use the user current location to provide weather data. For interaction, user click the use current location button to allow the app to access their geolocation and fetch weather data based on their coordinates. It is display current weather and forecast. The feature is the app display the current weather along with the 4 days forecast for the selected location. Interaction. After fetching the weather data, the app show current temperature, wind, speed, humidity, and weather condition for the next 4 days. Number 4 is temperature conversion, Celsius or Fahrenheit. User can toggle between Celsius and Fahrenheit for the temperature display. So, user click the C or F button to convert temperature between Celsius and Fahrenheit. And lastly is temperature trend visualization. The app provides a line chart that visualizes temperature trend over the next 4 days. User can view the temperature trend chart, which updated based on the selected city or the current location.
So, as you guys can see from this button, the function begins by retrieving the logged-in user from local storage. If no user is logged in, it prompts the user to log in first. If a user is logged in, it fetches their start log, formatted as JSON, and construct a simple HTML table encapsulating the log detail, such as timestamp and action taken. The function then read this HTML table in a full HTML document structure and use a block to encapsulate this data. You can see this table in the next slide, which is then linked to a dynamically created anchor element with the download attribute set to trigger the download. By clicking link.click, the download process is programmatically initiated, allowing the user to download the interaction log. For the local storage, first we will retrieve the current user username from local storage to ensure that the user is logged in. Next, we fetch existing log from local storage or initialize an empty array if none exists. After that, we create a new log entry with the user action and the current timestamp. Then, we will append the new log entry to the existing log array. Finally, we will save the updated log array back to local storage, ensuring all user actions are recorded persistently. So, for this application, there are two. The first one is example usage, which login function can be called after specific user action, such as clicking a button or submitting a form or changing setting. Next, there are debugging functions.
Now, let's dive into the key design choice. We will cover 3 main aspects: typography, color scheme, and layout. First is subslide, is typography. Typography play a significant role in readability and aesthetics. For our design, we choose Open Sans for its clean and modern look. It provides good legibility across different devices and screen size. Second is subslide, color scheme. Color scheme affect the mood and usability of the interface. We selected a primary color #007BFF for our header and buttons, creating a sense of consistency and brand identity. We also use contrasting colors for text to ensure readability. Then subslide layout. Layout is about arranging elements in a way that guides user intuitively. Our design used a flexbox layout, making it responsive and adaptable to different screen size. Responsive design ensures that our interface looks and works well on any device. Let's see how our interface adapts to different screen size. First is subslide desktop view. In the desktop view, we utilize a a wider layout to display more content side by side. Elements like weather cards and current weather section are spread out, providing a comprehensive view. Next is sub-slide tablet view on tablets. The layout adjusts to fit a narrower screen, where the cards shrink in size and the number of columns reduces, ensuring content remains readable and accessible. Sub-slide mobile view. For more mobile device, the layout stacks elements vertically, optimizing for one-handed use. The font size adjusts and buttons become more prominent to enhance touch interaction. As you can see, media queries allow us to adjust the layout based on screen width. This ensures our interface remains functional and visually appealing on all devices. Interactive elements like buttons and inputs are crucial for user engagement. We design our button with clear calls to action using distinct colors for different states. Hover effects provide visual feedback, enhancing the user's experience.